A few more examples of trigonometric identities and a little bit more rigorous algebra as we go along. So we have this 1 plus cos x plus times 1 minus cos x is equal to sine square. So similar to the previous video, one of the things we saw sometimes was being able to multiply these out. And so what we're going to do is we're going to FOIL. So we're going to take first, outer, inner, last. Okay. And so 1 times 1 is 1. 1 times negative cos x is negative cos x. 1 times cos x is going to be a positive cos x. And then cos times cos is going to give us a negative, or cos times negative cos is going to give us a negative cos square of x. All right. And that's just by multiply. And now we can clearly see that the cosines cancel out. So this is going to end up being 1 minus cos squared of x. Okay, so that's just like terms. And then finally, if we go all the way back up, we can see that 1 minus cos square is a Pythagorean identity. All right, so, and this is something that we talked about when we first introduced the Pythagorean identities, was that sometimes what you have to do is you just have to go through and maybe move one of the terms to the other side. All right, so if I was to subtract cos square, we can see that sine square of theta equals 1 minus cos square of theta. All right, and so going back down here, 1 minus cos square is going to be sine square of x in this case, and that's just by our Pythagorean identity. All right, so pretty easy proof after you've seen the steps of it, but maybe initially it looks like it's going to be a lot harder than necessary. All right. So the next one we have is going to be this tan x plus cotangent of x equals secant times cosecant. All right, so let's operate on the left-hand side, all right? And we can use our ratio identities because remember we said that the tangent is going to be sine over cosine. So that's sine x over cos x. And then the cotangent is going to be our cosine over sine. Let me move these a little bit so that way we have a little bit of room to work with. So the tangent is going to be our sine x over cos x. And the cotangent is going to be cos x over sine x. All right. And again, that's just by going through and using our ratio identities. All right. So now what we'd like to do is we'd like to be able to add these fractions together. And we know that to add anything, we have to have a common denominator. All right. So it looks like that for this one, our least common denominator is going to be the product of the denominators, which is going to be sine x cos x, right? And so what I'm going to do is I'm going to multiply each of those by whatever's missing. So in other words, over here, notice that the denominator is missing a sine of x. So I'm going to multiply this by sine x over sine x. And then over here, I'm going to multiply this by cos x over cos x, right? And so we could just say ratio slash multiply, okay, to get LCD. Right. And so now what we could do is just multiply those together, right? And so if we do so, this just becomes sine times sine is going to be sine square, cos times cos is going to be cos square. So we get sine square x over sine x cos x plus cosine square x divided by sine x cos x. And that's just by multiplying. Right? Now what we could do is we can now combine those into a singular expression because they have a common denominator. So we have sine square x plus cos square x divided by sine x cos x. Okay, so that's just by adding. We know that sine square plus cos square is 1 by our Pythagorean identity. So this is going to be 1 over sine x cos x. Okay, so that's our Pythagorean. And one thing that we can do is we can split this denominator up into 1 over sine times 1 over cos. Okay, so we can write this as 1 over sine x times 1 over cos x. Okay, that's just by multiplication. And then finally, just about ran out of room, so let me erase really quickly. What we could do, or actually I can just bring it down here. What we could do is we could just go ahead and say this is going to be by our ratio identities. We know that 1 over sine x is cosecant of x, and we know that 1 over cos x is the secant of x, right? And if we go all the way back to the beginning, that's exactly what we were looking for, sec x times cosecant of x. All right, so we're good there. Even though they're flipped around, we can certainly just multiply those together, okay? So that's going to be by our reciprocal identities. All right, one last example in this video, and this is a pretty sneaky one. We have this 1 plus tan square over sec y plus 1. Now, what we can do first is we can get a common denominator, okay? And clearly this is the more difficult side. And remember, you always want to start by manipulating the more difficult side. So the common denominator would be sec y plus 1, all right? So what I'm going to do is I'm going to rewrite 1 as sec y plus 1 divided by sec y plus 1, all right? And then we're still going to add tan square y divided by sec y plus 1. Okay, so that's just by getting an least common denominator. And then what we're going to do is we're going to combine these into one fraction. So now we can write this as secant of y plus 1 plus tangent square of y divided by sec y plus 1. All right, now here's the sneaky part. All right, let's try to get everything in terms of secants if we can. Right? And one thing that we can probably remember is that if we have these memorized, that the tangent has a Pythagorean identity. Okay, and you probably remember that the secant square is equal to 1 plus tan square. All right, so we go all the way back up here, and 1 plus tan square is equal to secant square. All right, so what we could do is we could isolate tangent square by subtracting 1 from both sides. And notice what we could do is we could write this as tan square of theta equals secant square of theta minus 1. All right, so let's do that by our Pythagorean identity. Okay, so we're going to go all the way back down here, and we're going to say that this is now, again, this is just by adding. Okay, and now what we could do is we can use that Pythagorean identity, and we can rewrite tan square as secant square minus 1. So now we have sec y plus 1 plus sec square y minus 1, okay? And still that's over secant of y plus 1, okay? So that's by our Pythagorean identity. All right. And now we can cancel out the 1's pretty clearly by adding. So now we get sec y plus sec square y divided by sec y plus 1. Okay, so that's just by adding. Now, here's the sneaky part. Notice that there's a common secant between these two. So let's factor out a greatest common factor of secant y. So now I'm going to pull out a secant of y. And if I factor a secant of y from secant of y, that leaves me 1. If I have secant square and I factor one of those out, that's going to be a secant y. And then we still divide that by sec y plus 1. Okay, so that's just by our GCF. And notice that in the denominator and the numerator, there's a common factor of sec y plus 1, or 1 plus sec y. If we really wanted to, we could flip these around, but we're not going to be that meticulous about it. And so all we're left with is the secant of y, all right? And that's exactly what we needed, okay? So that's just by canceling common factors. And we are done with this proof, all right, or this verification. All right, so again, that's how we can go through and try to verify, all right, and now you're starting to see some of the more difficult operations with multiplying and factoring with our trigonometric functions, okay? So if you're not too good with those, all right, what I would suggest is looking back at the videos a few times, making sure that you're okay being able to do those at this point before you move on, because again, these are going to get a little more rigorous as we enter our final videos for this series.